4.3 Permutations when all objects are distinguishable. Yesterday what we did is we talked about the beginnings of factorial notation and the beginnings of permutations. Today we're going to go a little bit deeper into the permutations, and I want you to take down this formula because it's real important. N P R or N pick R equals N factorial over N minus R factorial, where N is the number of objects to pick from. So it's kind of like the pool of objects. And R is the number of objects you pick. Okay, I'm going to be very intentional about my language around picking and choosing. That sounds kind of funny. Pick is for permutations and choosing is for combinations, but again, that will come up in later lessons. There are tons of different ways that we can approach questions surrounding permutations. We can use the fundamental counting theorem like we were yesterday, and we can also use this formula that I just gave you. We can also use our calculator, which is a beautiful thing. I'm going to show you all three on this next question. So example number 1, solving a permutation problem where only some objects are used in each arrangement. Matt, our buddy Matt, has downloaded 10 new songs from an online music store, iTunes, but we can't say that. He wants to create a playlist using 6 of these songs arranged in any order. How can different 6-song playlists be created from his new downloaded songs? So, method 1. This is the one that you feel comfortable with or have seen before from yesterday. I say, okay, there are 6 spots on this playlist. Due to the fundamental counting theorem, we know that we're multiplying. We say in the first slot on the playlist, we have 10 songs available. We don't want to have the same song over and over and over again, though I have been known to do that. We want to have distinct playlists. So then after that, 9 songs are available for the second slot. Then 8, then 7, then 6, then 5. When we multiply all those things together, we're going to get a huge honking number, which is 151,200 playlists. Woo! That's a lot. Let's talk about method 2, and we should get the exact same number. We're going to use our formula. N pick R is N factorial over N minus R factorial. Now we know that N is the amount of objects that we can choose from, so we know that there are 10 songs to choose from. However, not choose, I should say pick. R is the number of songs that we actually do pick, which is 6. And then I just plug in N as 10 and R as 6. So 10 pick 6 is 10 factorial over 10 minus 6 factorial. I get 10 times 9 times 8 times 7. Actually, I'm going to not skip this step here. I'm going to get 10 factorial over 4 factorial. I can go 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial, because I can cancel with 4 factorial in the bottom. And what I'm left with here is 151,200 playlists. Because we just have the same as here, 10 times 9 times 8 times 7 times 6 times 5. 10 times 9 times 8 times 7 times 6 times 5, because the 4 factorials cancel in both the numerator and denominator. Method 3, calculator. So you can just see, you can watch me as I punch the numbers in. I'm going to say 10 pick 6 go here. Now, I'm gonna put in my first number first, so 10. And then I'm gonna go to math. I'm gonna go under probability, and I'm gonna go under option 2 here, N, pick, R. And after it, I'm gonna put my 6. I'm gonna hit enter. Look at that! It does all that calculation work for me. How wonderful is that? So it's 151,200 playlists. So 3 different methods, all getting the exact same answer. Whichever one you feel most comfortable with is the one you go with. Sometimes you are going to have to show your work, and I'm going to specifically say on a test or exam that you will need to use the definition of, the mathematical definition of permutation. And so that means I want you to show all your work like this. However, if it just asks you the question as it is, you can literally just plunk it into your calculator.